The last thing I want to show you with some imaginary numbers is the power of I. And I'm going to start drawing a little bit of a table to kind of help you understand where I'm going with this. We know that I equals an I. What does an I squared equal? Do you remember? That was -1. What about I cubed? Well, I cubed, if we remember how to multiply bases with exponents, this is an I squared times an I, or a -1 times an I, which gives me a -I. What about I to the fourth? Well, that's I squared times I squared, or -1 times -1, which is a positive one. I to the fifth, well, that's I to the fourth times I, or just I. And what you start to see is that this pattern repeats. Every power of I is either an I, a -1, a -I, or a 1. So let's say, for example, I want to ask you what I to the 12th is. Well, the best way to do that is break this down to a 4. I mean like this, I to the 4th, and to make these equivalent, I to the 4th has to be raised to the 3rd power to equal I to the 12th. Now, why do you think I chose I to the 4th as this element here rather than I to the 3rd or I squared? Well, because I to the 4th is a 1. And I like numbers 1s. So this equals 1 to the 3rd, or just 1. So I know that I to the 12th, if I kept going on this pattern, I to the 12th would equal a 1. Let's look at a couple other ones. Say, for example, I to the 39th. How would you break that down? Well, I want to break it down in terms of I to the 4th. So I to the 4th, to what exponent do I have? Well, I to the 4th, I can't multiply that in such a way to get exactly 39. So I'm going to have to go I to the 4th to the 9th. Because that's I to the 36th, and then I have I cubed left over. Maybe a better way to say that is, let's look at I to the 39th, and let's find out what's the largest multiple of 4 that goes into 39. That's I to the 36th, and then what's left over is I to the 3rd. And this multiple of I to the 36th, that's going to be I to the 4th to the 9th power times I to the 3rd power. And again, I want to just to demonstrate this I to the 4th idea. That's just 1. 1 to the 9th essentially makes that go away, so I'm just left with an I third. So I to the 39th reduces down to I to the 3rd, and I to the 3rd was a -I. My goal is if I can reduce these problems all down to one of these first 4, and these first 4 you need to remember, I can determine what a simplification is. All right, let's look at one more. How about I to the 50th? What would you do in this problem? Well, the first thing I would do is write it down as I to the 48th, because that's the largest multiple of 4 before I run into 50, and I'm left over with I squared. Well, I to the 48th, well, you see that's going to become a 1, but let's do it anyway. So it gives I to the 4th to the 12th power, 12, 24, yep, to the 12th power times an I squared. I to the 4th to the 12th is a 1 times an I squared, and that equals just I squared. I squared is a -1. So I to the 50th is -1, and that's the simplification when we have powers of I.